So we've talked about a couple of characteristics of solutions. We've talked about molarity and how to figure out molarity by weighing out grams and moles or by diluting. Now we're going to shy away from concentration and molarity and talk about acids and bases, because some solutions are acidic, some are basic, and some are just neutral. So let's take a look and see what that means. We're going to start our discussion with acidic solutions. So our first question is, what are the characteristics of acidic solutions? So whenever we're talking about acids and bases, we always have to talk about what are called indicators. Okay, so we have a couple of different types of indicators. Indicators are just substances that make a color change in the presence of other substances, which are acids or bases. So acidic solutions are going to turn cabbage juice pink. Okay, they're going to turn what's called a universal indicator. It's just a different type of indicator. So we have cabbage juice indicator. We have universal indicator is going to turn it red through yellow. Okay, red, orange, or yellow. It turns litmus paper. Okay, red. Okay, so if we see here that cabbage juice turns pink, which is a shade of red. Universal indicator turns red or reddish orange. Blue litmus paper turns red. So the key color for acids is red. Okay, acids are going to, in the most part, be red when we put them on indicators. So if you see down here, this is cabbage juice. This is the scale for a universal indicator, and then this is what the litmus paper looks like. So it turns the blue litmus paper red, and it doesn't turn the red litmus paper anything. It just leaves it red. All right, so red is the key color for acids. Another characteristic of acids is that it reacts with a substance called calcium carbonate. Acids are also going to taste sour, they're going to sting your skin, and they do conduct electricity, which is interesting because if something conducts electricity, that means that it has ions in it, charged ions. So they break apart, the substances when they're dissolved in water are going to break apart into charged ions and be able to conduct electricity. Okay, so those are all the characteristics of acids. Let's take a look at bases. Okay, so basic solutions are going to turn our cabbage juice green or blue. Okay, they're going to turn the universal indicator to the blue-green side. They're also going to turn red litmus paper blue. Okay, they're not going to change the blue litmus paper at all. So we can see here that bases, okay, if we think of a color for bases, bases are going to be on the blue side. Okay, so acids are red, bases are blue. Now, basic solutions do not react with our calcium carbonate. Okay, so they don't react with it. They're going to taste very bitter. They're going to be very slippery on your skin. And they also conduct electricity, means that there's charged ions in them as well. And in the next coming weeks, we're going to talk about what those charged ions are. All right, so those are basic solutions, some characteristics of basic solutions. Now let's talk about those things that are right there in the middle that are neither basic nor acidic. Okay, so neutral solutions, okay, are going to leave the cabbage juice purple. Okay, they are going to turn the universal indicator just kind of a yellowish green, yellow, kind of right there in the middle here. Okay, and they don't turn the litmus paper any color. So the red stays red, the blue stays blue. There's no change in color at all. And just like the bases, they don't react with our calcium carbonate either. Neutral solutions don't really have a particular taste. Some taste plain, some taste salty, but they don't, they don't really have a particular taste. They don't react with your skin. okay, which is good. And as far as conducting electricity, some do, some don't. So it's, it's kind of up in the air. So neutral solutions don't really have like, a specific set of characteristics. They don't have a specific color they turn things. It's like, well, they taste this way or that way. They conduct and they don't. So it's not really, set, kind of set in stone. There's lots of different characteristics that they have. All right, so those are neutral solutions. The last thing that we're going to talk about is what's called a pH scale. Okay, so this is how we measure the acidity or basicity of a solution. It's called the pH scale. Basically, it's just a number line from 0 to 14 that indicates, how acidic or how basic a solution is. So numbers are associated with the colors. Remember, we saw that the acidic solutions are going to be here from 0 to 6, and they're going to turn it the reddish orange color. And basic solutions are from 8 to 14, and they turn it, on the blue-green to blue side. And then right there in the middle, we've got neutral substances, which are pH 7, and they're right there yellowish green in color. So that is the pH scale. So if you just remember, 0 to 6 is acidic, okay? 8 to 14 is basic, or what we call alkaline. It's the same thing as basic. And then neutral is right there in the middle. Okay, so when we come back next time, we're going to talk about what we're actually measuring when we're measuring the pH of something. For now, that's all. Nice and short. Enjoy.